In this video, I will consider one numerical to find Y parameters. For the network shown below, find admittance parameters. Admittance parameters are also known as Y parameters. This is the given circuit. For this circuit, we are supposed to calculate Y parameters or admittance parameters. So this is the given circuit. Let V1 is the voltage between port 1 1 dash, that is 1 1 dash, and V2 is the voltage between node 2 2 dash. Here we can see that this node is directly connected to 2 2 dash, that is voltage at node 2 is V2, therefore voltage at this point is V2 itself. Here, because of this resistor, voltage at this point is not same as V1. Let me assume voltage at this point is say Vx. Now I will try to solve or try to find admittance parameters by applying node analysis method. It will be very easy. Let me assume current through this branch is I1, that is input current. Current here is I2. Now let me assume current through this branch is say X, current through this branch is say Y, and current through this branch is say Z. So we know that the admittance parameters are represented as, let me write Y parameter equations, that is the admittance parameters are given by, we have I1 is equal to Y11 V1 plus Y12 V2, and we have I2 is equal to Y21 V1 plus Y22 V2. Let me call it as equation 1, this as equation 2. Now in this circuit, first apply KCL to node Vx, that is apply KCL to node Vx. So we know that incoming current is equal to outgoing current. Here current I1 is incoming, where X and Y are leaving node Vx. So I can write I1 is equal to X plus Y, or I can write I1 is equal to, I can express X in terms of node voltage as X is nothing but Vx divided by 2. That is X is nothing but Vx divided by 2 plus, so Y is the branch current which is flowing from Vx towards V2. So I can write Y is equal to Vx minus V2 divided by 3. That is potential difference between this node and this node divided by 3, because current is equal to voltage by resistor. So Y can be expressed as Vx minus V2 divided by 3, minus V2 divided by 3. Let me simplify this, or I can write I1 is equal to Vx by 2 plus Vx by 3 minus V2 by, or I can write I1 is equal to Vx in bracket 1 by 2 plus 1 by 3 minus V2 by 3, or I can, let me simplify this further. That is I1 is equal to Vx 1 by 2 plus 1 by 3, it gives 5 by 6 minus V2 by 3. Let me call it as equation A. So now here I can try to get the value of I1. So I1 is nothing but V1 minus Vx divided by 1. That is, here I can write I1 is equal to V1 minus Vx divided by 1. So from this, I can simplify this as I1 is equal to V1 minus Vx, or I can write Vx equal to V1 minus I1. So now let me substitute Vx value, that is V1 minus I1, in this equation. So I will call it as equation B. Now, so therefore, substitute B in A, or I can write I1 is equal to, we have Vx is nothing but V1 minus I1, that is V1 minus I1, we have 5 by 6, then minus V2 by 3, or I can simplify this as I1 is equal to 5 by 6 V1 minus 5 by 6 I1 minus V2 by 3, or I can write it as I1 plus 5 by 6 I1 is equal to 5 by 6 V1 minus 1 by 3 V2, or I can write it as I1 1 plus 5 by 6 is equal to 5 by 6 V1 minus 1 by 3 V2, or 1 plus 5 by 6 that is I1 into 11 by 6 is equal to 5 by 6 V1 minus 1 by 3 V2, or simplifying this I can get I1 is equal to, so it is 5 by 6 into 6 by 11, so 6 will get cancelled, will get 5 by 11 V1 minus, we have 1 by 3 or 6, 1 by 3 into 6 by 11 V2, or I can write, I can continue here, I1 is equal to 5 by 11 V1 minus, we have 3, 6 by 3 is 2, that is 2 by 11 V2. Now let me call it as equation C. So now let me compare equation C with equation 1. Here we can see that I1 is equal to Y11 V1, coefficient of V1 is Y11, coefficient of V2 is Y12. So here we have coefficient of V1 is 5 by 11, coefficient of V2 is minus 2 by 11. Therefore, now compare equation C with equation 1. With equation 1, therefore we can write Y11 is equal to 5 by 11, Y12 is equal to minus 2 by 11. So these are the first two parameters. So now to the same circuit, now let me apply KCL to node V2. That is, now apply KCL to node V2. So here we have Y is incoming current, I2 is incoming current, Z is outgoing. I can write Y plus I2 is equal to Z. That is Y plus I2 is equal to Z, or I can write it as I2 is equal to Z minus Y, or I can write I2 equal to, I will express these Z and Y currents in terms of voltages. So here we can see Z is nothing but V2 divided by 4. So Z is V2 divided by 4 minus, so here Y is nothing but Vx minus V2 divided by 3. That is Vx minus V2 divided by 3. Now let me simplify this. I2 is equal to V2 by 4 minus Vx by 3 plus V2 by 3. So now substitute Vx value, that is Vx value from equation B in equation in I2. So here substitute Vx value from equation B in above equation. So I can write I2 is equal to V2 by 4 minus Vx is nothing but V1 minus I1. That is, I can write V1 minus I1 divided by 3 plus we have V2 by 3. So let me simplify this further, or I can write I2 is equal to V2 by 4 minus V1 by 3 plus I1 by 3 plus V2 by 3. Let me simplify this further. I2 is equal to, we have V2 by 4 plus V2 by 3. 1 by 4 plus 1 by 3. It gives 7 by 12 V2. That is 7 by 12 V2. Then we have minus 1 minus V1 by 3 plus I1 by 3 plus I1 by 3. So now in this equation we can see that we have the variable V1, V2 and I2, but there is one more extra variable, that is I1. So now we'll try to substitute the value of I1 from equation C. So that is substitute. Now I can call it as equation D, that is substitute I1 value from equation C in D. So I can write I2 is equal to 7 by 12 V2 minus V1 by 3 plus 1 by 3. We have I1 is nothing but 5 by 11 V1, 5 by 11 V1. Then we have minus 2 by 11 V2, 11 V2. Or simplify this further, I2 is equal to, we have 7 by 12 V2 minus V1 by 3 plus 5 by 33 V1 minus 2 by 33 V2. Or I can write it as I2 is equal to, we have 5 by 33 minus 1 by 33. That is, I can write V1 minus 1 by 3 plus 5 by 33 plus we have V2 in bracket 7 by 12 minus 2 by 33. Simplifying this, I can write I2 is equal to, so it gives minus 2 by 11 V1 plus, here we have 7 by 12 minus 2 by 33, 23 by 44 V2. So now we'll call it as equation E. So now compare equation E with equation, we have 2, equation 2. Therefore we can write y21 is equal to minus 2 by 11 and y22 is equal to 23 by, we have 23 by 44. These are the required parameters. So now I will solve the same problem using another method. So whichever you feel comfortable, you can use. So this is the given circuit. We know that the admittance parameters are given by these two equations. Here we can see that to find y11 and y21, if we make v2 equal to 0, we'll get these two parameters. Similarly, if we make v1 equal to 0, we'll get y12 and y22. So first let me make v2 equal to 0. That is, v2 equal to 0 means making voltage source equal to 0. Making voltage source equal to 0 means we have to short to 2 dash. So now let me make v2 equal to 0. That is, so that is, let v2 equal to 0. That is, short terminal to 2 dash. So we have to short this terminal to 2 dash so that v2 will become equal to 0. Let me do that. So here we have 1 ohm resistor. This is 2 ohm. Here we have 3 ohm. Here we have 4 ohm, and here this part is shorted. This was 2 dash, and here we can see that the voltage is V1, and we have assumed that current flowing here is I1. So here we can see that current is I2. When we short this, the same current will appear, that is I2. So here we can see that 2 dash is shorted. It means that parallel to shorted path there is a resistor, so no current flows in this resistor, so we can ignore this resistor. Though this circuit is equivalent to this circuit, that is here it is V1, we have I1, this is 1 ohm, 2 ohm, 3 ohm, and we can see that this current I2 will appear here like this. So this was terminal to 2 dash. So now in this circuit I will try to apply KVL and I will try to find the currents. So the current in this loop is I1. Let me assume current in this loop is say Y. Let me apply KVL to the first loop. I can write V1 is equal to 1 I1 plus 2 I1 minus Y, or I can write V1 is equal to 3 I1 minus 2Y. Let me call it as equation 1. So now I'll apply KVL to this loop. I can write 0 is equal to, as there is no any voltage source, voltage drop across 3 ohm resistor is 3Y plus same current flows through 2 ohm resistor, that is 2Y minus I1, or I can write it as 5Y minus 2I1, or I can write it as 5Y is equal to 2I1, or I can write Y is equal to 2 by 5 I1. So here we can observe that Y is the current which flows through 3 ohm resistor in this direction, whereas I2 is flowing in opposite direction. So Y current is nothing but I2, but opposite to each other. So Y is nothing but minus I2 also. So now let me substitute Y value in equation 1. Therefore I can write equation 1 becomes, we have V1 is equal to 3I1 minus 2 into Y. Y is nothing but 2 by 5 I1. 2 by 5 I1, that is V1 is equal to, we have 3 I1 minus 4 by 5 I1, or V1 is equal to, we have I1 3 minus 4 by 5. So simplifying this, we'll get V1 is equal to 2.2 I1. So here I can say that when V2 is 0, Y11 is equal to I1 by V1, and when V2 is 0, Y21 is equal to I2 by V1. So therefore Y11, let's calculate Y11, which is I1 by V1. So Y11 is equal to I1 by V1, which is equal to, so here I1, V1 is nothing but 2.2 I1. So I can write, I will keep numerator I1 as it is. V1 is nothing but 2.2 I1, which is nothing but 1 upon 2.2, which is nothing but 5 by 11. So Y11 is equal to 5 by 11. So similarly, Y21 is equal to, so from this expression we can see that I2 by V1, that is I2 by V1, which is equal to, as I said here, I2 is nothing but 2 by 5 I1. So it is minus 2 by 5 I1 divided by, we have V1. V1 is nothing but 2.2 I1. 2.2 I1, which is equal to minus 2 by 5 into I1. I1 will get cancelled, 1 upon 2.2. So simplifying this, will get minus 2 by 11. So therefore we found first two parameters. Y11 is equal to 5 by 11, and we have y21 is equal to minus 2 by 11. So these two parameters we got by shorting to 2 dash or output port. Now to find y12 and y22, we should short v1. We have to make v1 equal to 0. So making v1 equal to 0 means we have to short terminal 1 1 dash. So therefore now now to find y12 and y22, short terminal 1 1 dash, that is v1 equal to 0. So in that case we'll get y12 is equal to, so from here y12 is equal to I1 by V2, I1 by V2, and we have y22 is equal to I2 by V2. Now let me draw the circuit. So here we have 1 ohm, here we have 2 ohm, here we have 3 ohm, here we have 4 ohm, and it is connected to this terminal is shorted. So this is 2 2 dash. Here we have voltage V2 and here current was I2. So here we made 1 1 dash shorted. The current flowing here is I1. So now I will try to simplify this. So here we can see that 1 ohm and 2 ohm are in parallel. That is 1 is parallel with 2. Then this combination is in series with this. It will become 3. Then this whole combination will come in parallel with this. That is this will come in parallel with 4. That will become my equivalent resistance. So let me find equivalent resistance first. First I will do this. So 1 parallel with 2 is nothing but 2 by 3 plus 3. Then this combination is parallel with 4, or I can write 2 by 3 plus 3 is nothing but 11 by 3 is parallel with 4, or I can write 11 by 3 into 4 divided by 11 by 3 plus 4. So it gives 44 by 23. That is R equivalent equal to 44 by 23. So I have reduced this circuit to like this. This is 44 by 23, and here we have V2 plus minus, this is I2. So from this I can write V2 is equal to 44 by 23 I2. So therefore now I can find Y22. Y22 is equal to, we have I2 by V2, I2 by V2, which is equal to I2 divided by 44 by 23 I2, or I can write Y22 is equal to, I2 will get cancelled. 1 upon 44 by 23 is nothing but 23 by 44. So we found another parameter, that is Y22. So now let me find Y12. So now here to find Y12, so as we know this current I2 will flow at this node, the current will divide. Part of the current will flow here, part of the current will flow here. I will call this current as IZ. So first I will try to find IZ because I want I1. I1 is here. So I want to calculate I1 first. So first, before that I will find IZ. So that same current IZ will divide at this node. Part of the current will flow here, part of the current will flow here. The current through this branch is nothing but I1. So I will try to find. So now here to find IZ, I can reduce the circuit as this 1 ohm and 2 ohm are in series parallel. That combination is in series with this. That is 1 is parallel with 2 in series with 3. The value of this is 2 by 3 plus 3, which is nothing but 11 by 3. Now the equivalent resistance between 1 ohm, 2 ohm and 3 ohm is nothing but 11 by 3, which is in parallel with 4. Let me draw that. So here we have equivalent value 11 by 3. which is in parallel with 4. So here it is I2 and this is V2, and here we can see that this is IZ. So here I have shown IZ, which is nothing but this. Now I will apply current division rule. IZ is equal to total current into opposite resistor, that is V2, divided by sum of resistors, that is 11 by 3 plus 4. So simplifying this, IZ is equal to total current I2 into 4 opposite resistor divided by sum of resistors, that is 11 by 3 plus 4. So simplifying this, we will get I2 into 4 divided by 11 by 3 plus 4 is nothing but 23 by 3, or I can write it as I2 into 4 into 3 divided by 23, or I can write IZ is equal to 12 by 23, it is I2. Now come back to this circuit. This IZ will flow here. At this node, the current will divide. Part of the IZ will flow here. That is, part of the IZ will flow here, and part of the current will flow here. The current flowing through this branch is nothing but minus I1, because this is opposite to this. So now let me find this current. Once I find this current, the opposite of that, the negative of that will be I1. Let me call this as Ix current. So I can say Ix is equal to, so Ix is nothing but current, total current is Iz here. So that is total current Iz into opposite resistor. Opposite resistor here is 2. 2 divided by sum of resistor, that is 2 plus 1, that is 3, which is equal to Iz is nothing but, already we have calculated here, 12 by 23 I2 into we have 2 by 3, 2 by 3, which is equal to 24 by 69 I2. So therefore we can say I1 is equal to minus Ix, which is equal to minus 24 by 69 I2. So this is nothing but minus 8 by 23 I2. So here we can see that Y12 is equal to I1 by V2. That is Y12 is equal to I1 by V2, which is equal to I1 is nothing but minus 8 by 23 I2 divided by V2. So we have divided by V2. V2 is nothing but, already we have found 44 by 23 I2. That is nothing but 44 by 23 I2. Or I can write minus 8 by 23 into, this is 23 by 44 into we have I2 by I2. So simplifying this, here I2 will get cancelled, 23 will get cancelled, will get minus 8 by 44. So which is nothing but minus 2 by 11. So therefore we have Y12 is equal to minus 2 by 11. Yes. Thus we found all the parameters and we got the same answer from both the methods. Thank you for watching.